What is the history of computational stress analysis methods? Imagine trying to figure out how a bridge or an airplane wing will hold up under pressure without actually building it first. That's where computational stress analysis methods come into play. These techniques help engineers predict how materials and structures will respond to forces, heat, and other factors. But how did these methods come to be? Let's take a quick journey through their history. It all started after World War II, when electronic computers first appeared. Engineers and mathematicians needed ways to solve complex problems faster than ever before. They developed numerical methods like Monte Carlo simulations, decomposition, and iterative techniques. These tools allowed them to solve large systems of equations that describe physical phenomena, including how stress and deformation happen in materials. A major breakthrough came in the 1950s with the creation of the Finite Element Method. Engineers like Alexander Hrennikoff and Richard Courant laid the foundation by dividing structures into smaller pieces called elements. This made it easier to approximate how each part would behave under stress. Ray Clough in 1956 coined the term Finite Element Method and pushed it forward by creating automated programs. These programs could analyze stress concentrations and fatigue failures in structures like ships and bridges. By the early 1960s, the finite element method was used in real projects, such as analyzing the stress in the Norfolk Dam in Arkansas. Faster computers like the IBM 700 allowed engineers to make more detailed models with finer meshes, improving accuracy. As computers became more powerful in the 1960s and beyond, the methods expanded to include nonlinear and three-dimensional problems. This made it possible to analyze complex structures in aerospace, civil engineering, and materials science. Today, engineers relying heavily on software that uses the finite element method to perform stress calculations quickly and accurately. These tools help design safer, more efficient components and structures by predicting how they will respond to loads, temperature changes, and operational conditions. The evolution of computational stress analysis methods from basic numerical techniques to advanced software has transformed how engineers approach design and analysis. In summary, the history of computational stress analysis methods begins with the development of numerical mathematics after World War II. The finite element method, introduced in the 1950s, became the central technique. Ongoing improvements in computers and algorithms have made these methods essential tools in modern mechanical engineering.